In order to burn, the fuel must be vaporized and mixed with air at the correct ratio. This job can be performed by either a carburetor or a fuel injection system. A carburetor contains an open pipe with a shaped restriction, or venturi, inside. The venturi momentarily accelerates the intake air, lowering its pressure and temperature. A fuel nozzle placed inside the venturi allows the lowered air pressure to pull fuel through the nozzle and into the intake air. The sprayed fuel quickly vaporizes in the air. Next, the fuel-air mixture encounters a throttle valve inside the carburetor. The pilot manipulates the position of the throttle valve to adjust the engine's power. At idle power, the valve is nearly closed, greatly restricting the flow of fuel and air to the engine. At full power, the valve is completely open. Air is cooled inside the carburetor as a result of the reduced pressure and the vaporization of fuel. The temperature can drop from relatively warm temperatures prior to the venturi to below freezing just after it. Ice can form inside the carburetor, restricting the flow of air to the engine and reducing engine performance. A pilot can counteract the formation of carburetor ice through the use of carburetor heat. The carburetor heat control in the cockpit moves a valve which directs intake air through a small heat exchanger. The heat exchanger uses hot engine exhaust to warm the intake air. The use of carburetor heat will also cause an engine performance decrease. This is due to the air being thinned as a result of being heated. However, it must be used to counteract carburetor ice, since continued ice formation will further reduce engine performance. Favorable conditions for carburetor icing are temperatures below 70 degrees Fahrenheit with a high humidity, although carb ice is possible at temperatures as high as 100 degrees. A fuel injection system uses a fuel injection pump to supply fuel under pressure to a fuel-air control unit. This unit meters fuel and air to the engine according to the throttle and mixture control settings. The metered fuel then flows to the fuel flow divider, which splits the fuel equally among the cylinders. Each cylinder has its own fuel injector, which vaporizes the fuel just prior to the cylinder's intake valve. Since there is no venturi in a fuel injection system, a fuel injection system is less susceptible to internal icing. The high temperature of the cylinder makes ice not likely to develop at the fuel injector either. Both carburetor and fuel-injected engines are susceptible to impact icing, which results when the airplane flies through visible moisture that forms ice on the engine's air intake or air filter. This impact ice blocks the flow of air into the engine. To counteract impact icing, many engines include a manual or automatic valve, which provides an alternate intake air supply.